Next example we are going to consider is this example. Let me read the example. The service life of a battery used in a cardiac pacemaker is assumed to be normally distributed. A random sample of 10 batteries is subjected to an accelerated life test by running them continuously at an elevated temperature until failure. And the following lifetimes in hours are obtained, 25.5, etc. So this data set can be seen in this list as well, in the first column. Okay, so the manufacturer wants to be certain that the mean battery life exceeds 25 hours. What conclusions can be drawn from this data? And we are asked to take alpha is equal to 0.005. We are going to first do this by hand, and then we are going to do this with using Minitab, and you're going to see how easy it is on Minitab. So first of all, sigma is unknown, so we are going to calculate the sample standard deviation S, and we are going to use it in t-distribution. So this question is one-sided t-distribution. We have x is normal distributed here, as you see, and a number of elements in data set is 10, and x bar and S are computed here by hand or on Excel, and mu 0 is 25 and alpha is 0.005. So our test hypothesis is, null hypothesis is mu is equal to 25, and null alternative hypothesis is mu is strictly greater than 25, because it says they're interested in whether the battery life, mean battery life, exceeds 25 hours. Because of that we have that. So we are going to reject A0 if T0 is greater than T alpha, yeah? So we have the formula for T naught, this test statistic for T, x bar minus mu 0 over S over square root of n. We have x bar 26, we have mu 0 25, which comes from our hypothesis testing, divided by S was computed 162 over square root of 10. And this is going to be equal to 1.952. And then next we compare this with T alpha and minus 1 value. Alpha is 0.005 and degrees of freedom is 9. So we get this value from T table. And when we compare these two, which is 1.952 and 1.833, we see that T naught is bigger than T alpha. Hence, we reject null hypothesis. So we can do this simply on Minitab as well. For that, we need to go to stat, and we need to choose basic statistics and one sample T. And here, usually we don't have anything in here. So when we click in here, we are going to get all these data set, and we choose this because it's our data set. And we want to perform the hypothesis test, so we click on this, okay? And then what's the hypothesized mean is 25 hours. And then we look at the options as well. In options, the confidence level is 95 because alpha is 0.005. And alternative hypothesis is mean is greater than 25, so we have to choose that. And we click OK. And graphs, we are not interested in graphs, so we click OK and we get the result. So in this result, we have exactly the same table we got here. We have extra 95% lower bound, which is 25058. We have it here too. And then the test results, the test is in here, okay? And then the t value is 195, as we found earlier by hand, and p value is 0042. So alpha is 0.005, p is 0042, p is less than alpha. So for any alpha value that's greater than this p value, we reject the hypothesis testing. So that's the answer to part A. In part B, on the other hand, they ask us to construct a 90% two-sided confidence interval on mean life in the accelerated test. So we have to go through this stat again, basic statistics, and one sample T. Here we have the same data, so we keep it. We perform the same test, however, it's going to be the confidence level is going to be 90% because our alpha is 0.10. And then alpha alternative hypothesis is two-sided, so we choose this for that. Now we click OK. So what do we get? We get one sample t. We have n, 10, mean everything here is the same. 90% confidence interval, it's given two-sided. Okay, which is this, which should be the same as this result, 25.606, 26.94. Okay, and then we go down here and then we look at the t value and p value. Okay, so they didn't do the Minitab test in part B, so we don't have the results for them. I don't think we do, but we have it here, and we compare p-value with the alpha. Alpha is 0.1, it is bigger than p-value, and we are going to say for any alpha bigger than p-value, we reject null hypotheses, and that's the end of the question.